All right, registration form is right there. And then I also wanted to mention we do have some upcoming events. All of our events, upcoming webinars, upcoming like study group sessions are always posted in the chat. Excuse me, in our Slack group. And so if you want to hear just more about upcoming webinars, you can join the Slack. Let's see here. It sounds, I'm seeing that my voice is breaking a little bit. I hope not too much, but I'll quickly get through what I have to get through and then pass it over to Daryn. Daryn, can you hear me all right?
I can hear you.
Yeah, you can. Okay. So yeah, very quickly, our next, we have an upcoming session, an RStudio instructor certification study session coming up. The next one is going to be October 31st, at the end of this month, from 2:30 p.m. to 3:30 p.m., and that's Eastern time. So if anyone is currently studying to become an RStudio certified instructor, you can join us and find community, ask questions, practice your exam together. We'd love to have you. And then the last thing, it looks like I'm not able to be heard very well. Okay, so one thing I would like to mention is that this session is going to be recorded. So I apologize for those that are not able to hear me very well. I'll try to work on that when I pass it over to Daryn. But just so you all know that you'll be able to find the video in full on YouTube, on the Meyer Community YouTube channel. Okay, so let me now get to what you're here for. A little bit about Daryn. Daryn is a trained mathematician and epidemiologist, currently working as a freelance data scientist, and is based out of Trinidad and Tobago. Daryn also received his RStudio instructor certification earlier this year, but has been contributing to our community for so long. So we're just thrilled to have him to come and share his favorite parts about Dplyr, some of the workflows that he has, all that good stuff. Okay, so the last thing I will do is I'll post the GitHub link to the slides and the materials for the webinar in the chat. If anyone has questions, I'm monitoring the chat, so I will just focus on the chat and not speak anymore. But yeah, I'll pass it over to you, Daryn. Thanks so much.
All right, thank you. Well, it's good to be here. It's good to see people in attendance. Let me know if you have any problems with like hearing me or anything like that, or with the visuals. So yeah, so thanks to Meyer, in particular to Danielle and to Doris for organizing everything, and also to my employer for using the office space, especially my boss whose desk I just moved to about 10 minutes ago. Yeah, so I've been using Dplyr for, well, 2 years ago, I had never used Dplyr. I'd been an R user for about 8 years before that, but I'd never used Dplyr. I was a base R user very heavily. Since starting with Dplyr, I have become a daily user of Dplyr. So I'm just gonna go over, I'm gonna try to do an overview of what I have found to be some of the most useful functions. And then I'm gonna try to cover some of the features that are more recent in the newer versions of Dplyr. So there was a URL with some slides sent out. I'll confess that I added a couple more slides. So if you just put +_ in the URL, you should get, that's, yeah, right. You should get the updated slides with, with 4 or 5 slides that I added to the presentation. All right, I'm gonna go with the dark mode because I prefer that one, unless people object strongly. All right, so yeah, so let's start. So the title is an overview of Dplyr. I'm Daryn Ramsden, that's my contact information, and then we have today's date, right? We're gonna use the Palmer Penguins data set. Okay, so I'm not so sure if it's going to be feasible for you to code along. you know, we kind of have a lot of stuff to cover maybe, but I'll try to type in some code, but there'll be code on the slides, but I'm not too sure how well it will work for you to be typing along. But we will be using the Palmer Penguins dataset, which you can get by installing the Palmer Penguins package and then using the library command to get Palmer Penguins. And in particular, we'll just be using this one data frame, penguins, right? So let me switch to, and I'll try to keep all the code that I type in a notebook, right? So, right. All right, let me view. Right. Okay, so this is the data frame, right? So what is the data frame? It's a collection of information about 344 penguins that were collected by some scientists over the years 2007 to 2009. We have 8 fields. You know, we have the species, which is the type of species, the island, which is where it was found, and then some physical dimensions of each penguin. The bill length in millimeters, the bill depth in millimeters, the flipper length in millimeters, the body mass in grams, sex, male, female, you see that there's some missing values, and then the year of the observation. Right, so let me go back to my presentation, right? So let me move this window out to the way, right? And in the slides, you can scroll through, you can page through the table and verify, right? So that's the data we'll be using. All right, so this slide is just some, you know, just writing out what those variables mean, just that I went over just now, right? All right, so now are we comfortable? Well, I'm comfortable with the data. I don't know if you are, but that's the data frame we're going to work with, right? So now we get to Dplyr, right? It's a package for data manipulation. The data you get is almost never in the form that you want, right? And in my experience, you know, the fundamental, you know, problem of working with data is getting the data in the form you want. And Dplyr is a very useful package for doing a lot of common data manipulation tasks, right? That is not what I was trying to do. Okay, wherever I put this picture of myself turns out to be the most inconvenient place to be. All right, so.
Hey, Daryn. Really quickly, could you post the link to the updated slides in the chat?
Yeah.
We've got some folks asking so they could view and follow along. Okay, perfect. Thank you.
It should be, yeah. Sorry, what's your time here? All right. All right, so some tasks that you might want to do when you manipulating data, like you already have it in R, so it's not really like a data cleaning thing really, or you know, or a data sourcing or anything like that. But sometimes you might want to only keep some of the rows, right? You have a large data set, but you're only concerned with a certain subset. Or you might want to keep only some of the columns. You might have a spreadsheet with 300 columns, but you only want 50 or 5 even. Or you want to add some new columns, or you want to sort the data, or you want to provide summary statistics, right? Because you know we can't contemplate raw data very well. We want summaries, right? So Dplyr has functions for each of these and many other functions. So I'll try to go over like some of what I found to be the most useful functions of Dplyr. All right, so basics, how do you use it, right? To get it, you use the installer packages function, and then use the library function to get access to the names, right? So if I switch over here, I go to library Dplyr. So now I can use certain names that are available in the Dplyr package. Okay, So there's our map of the key, so some key single table verbs or functions that we're going to go over. I took this straight from one of the vignettes, this list. I'm going to give examples of all but one of these. And if you ask, I'll probably do an example of the one that's missing if you notice which one, right? So some of the functions are for working with rows is filter. Filter allows you to keep only some of the rows based on the column values. Slice lets you keep some of the rows based on their location. Arrange is to sort the data. And then if you want to think about it in a column-centric manner, there's select, which will keep only some of the columns. Mutate, which will add new columns. Rename, which will change the name of specified columns. Relocate, which will change the order. And then working with groups, we use the summarise function and its helper function, group by. Well, now, that might be a lot, but we'll fill in the gaps and it'll make a lot more sense, hopefully. It'll make more sense. All right, so we'll start with filter, because filter is the first Dplyr function I ever used, and I think it's a good place to start, right? So we have the penguins data frame, right? So let me go back to, right? So we have the penguins data frame, right? So we're scrolling through and we see that there are 3 species, right? So there's the Adderley species. I'm not too sure how to pronounce it. The Gentoo and the chinstrap. Right? And I'm gonna sneak in a Dplyr function here that, well, by definition, I haven't used before, which is count. And so I'm counting penguins and I'm saying what I want to count. So I see that there's 152 of this of one species, 68 of another, and then 124 of the Gentoo species, right? Okay, so just doing by example now, right? How do we get all the penguins of the chinstrap species? So what we use is we use the filter command, right? So I'm gonna create a new data frame called chinstrap, right? This is the name I'm going to give to the output. I'm gonna call the filter function, and all of these Dplyr, all of these verbs that we're going to go through fit like a common format, which is that the first argument, first input, first argument, whichever terminology you're familiar with, is typically a data frame. And then followed by that, there are a variable number of conditions, right? So what I'm doing is I want to filter penguins, and then this is my condition. Species is equal to chinstrap, right? And I'm going to take that answer and I'm going to output it to this new data frame called chinstrap, right? And if I display chinstrap, I'll see, output to the screen, I'll see a table 68 by 8, which is not quite the entire data frame, the original data frame. And just looking at this first column here, that you can see that all these species are in fact chinstrap, right? Now, if I go back to RStudio, I can run that code. Let me type in that code, right? I'm gonna run that same. Right, if I run this code chunk, right? So I have a data frame, 68 observations of 8 variables called chinstrap, right? And we can scroll down and we can see that in fact, all of the species, all of the penguins in this data frame are indeed only of the chinstrap species, right? All right, so I'm going to introduce an alternative way to do that same thing. I'm going to use this operator called the pipe. Typically, I would go through all the functions before and then explain the pipe, but now I'm experimenting with just throw it in the pipe and seeing how it works, right? So the alternative way to do that, its equivalent, is to use this new notation, which is I'm saying penguins, and then I'm using the pipe. And I pronounce the pipe as into. So I'll say penguins into filter, right? So the pipe is a function which takes something from its left and sends it to the thing on its right. So this is equivalent to the previous notation. Instead of saying filter penguins and then saying species, right? We use the pipe notation where we take penguins and we send it into filter, right? So if you think about what a pipe is, right? In real life or in Mario Brothers, like a pipe is something that takes like a material and carries it somewhere else for it to be used, right? So you're taking this data frame, you're sending it to filter, and filter says, well, this is the data I've been waiting for. I'm gonna apply this condition that I've had waiting, right? So I do a chin strap 2, and I get another table, which is also 68 by 8, right? So I'll just go back to my script. I'm gonna say chin strap 2. I'm gonna say penguins. Well, filter. Right. So when I run this code chunk here, I see that I do have a new data frame in my environment called chinstrap 2, which has the same content as chinstrap, which I'm not going to show. Right. Okay, so just a little detour because the pipe operator. So it's kind of different, right? So it may be very different to anything you've ever seen in R if you're not familiar with it. So it's an operator. It's defined in the Magritte package, which you get for free in Dplyr or in TidyR or some other packages, right? So you don't have to import Magritte if you're importing the Tidyverse or Dplyr, right? So it's a called a pipe operator because it transfers data from one function to another. And I use it a lot. So as we go further along, I think you might see that my code has more and more pipes. And the reason I use it is because it makes sequences of operations much easier. You don't have to write any intermediate data frames, and you can apply them multiple times. So you can take a pipe, send it to a function, take that output, pipe it into something else. So you can, type all of your logic into one statement, which, unless it gets too long, is often convenient, right? Right. So, all right. So another example of using filter. Let me just check the chat here. All right. So how do we get all the penguins that are 4 kilograms or greater? So I don't know if you remember, but the body mass field in the data here is in grams, right? So if I want something to be 4 kilograms, what I want all the penguins that are 4,000 grams or more. That's not what I want to do, right? So I'm going to create this new data frame, penguins 4K. I'm going to say filter penguins, and I'm going to add this condition, body mass G greater than or equal to 4,000. Right, so penguins 4K, and now going from an original data frame of 344 penguins, I see that only 177 of them meet this criterion that the body mass be greater than 4 kilograms. And if you look at this column down here on the right, you'll see that indeed all these values are indeed 4,000 grams or more, right? So let me just jump back and I'll stick in another code here. right? So I have my penguins 4K, and we can see, if you scroll down, you see that all these are the, I guess, the larger penguins. I can't remember exactly why I chose 4,000, because it's a round number. All right. So here's a question now. What if we wanted, so we wanted two things at once. We wanted only chinstrap penguins, but they also have to have a body mass of 4 kilograms or greater, right? So that's like a combination of the two things we've done before, right? So how I do that is I'm still filtering penguins, but I'm given two conditions at a time, right? So I'm saying the species has to be chinstrap and the body mass has to be greater than or equal to 4,000, right? And here now, I have a much smaller data frame in that there are only 16 penguins that meet both of these conditions, right? So chinstrap 4K, right? Let me jump over here. Right. Right, so I run it like that. Alternatively, I could have used the pipe like this. So I'm gonna take penguins and send it into filter and then apply the conditions. Sorry, let me see in the chat there. Right. Okay. All right, so, well, I made this slide with, this says an assessment. So like a question, so I don't know if anybody's trying to follow along in the code, or if you could just think about it for a little while. So how would you find out how many penguins were found on the Torgerson Island? So in the data, there are 3 islands, right? Torgerson, Biscoe, and I believe Dream. Right, so there are 3 islands. Well, I've only shown you one function, filter. So if you could, put a little thought into how would you try to figure out how many penguins are on that particular island, Torgerson? Right. Yeah, I'll just wait for like a few seconds and then I'll just show the answer. So if anybody wants to think about it, right? I'll show an answer using that filter function, utilizing that filter function. Right, okay, so how do you do that? I'll create a data frame called Torgerson. I'm filtering penguins and I'm saying island equal Torgerson. And then I'm gonna use the dim function from base R, which gives you the size of a data frame. So you see it's a 52 by 8, so it's 52 rows by 8 columns, right? Also, you could use the pipe notation, say Torgerson, and you say penguins into filter, and then you take the dimension again, right? All right. So the next major function I'm going to talk about is select, which is a function for specifying which columns to keep. So as of Dplyr 1.0, there are 5 ways to select. Is you can select by the position, whereas you say, I want the first column and the 50th column and the 200 column, for instance. Or you can select by name, where you can say, I want the body mass column and the build length column and the species column. Or you can do by a function of name, or you can do by type, where you might want to say, I want all the numeric columns. And then the last thing is you might want to do a combination of any of the above. So I'll do some examples. Again, just everything is going through by examples. Right. All right, so select by position. This is the easiest one, right? I don't really use it that much. I never use it, to be honest, but it's there. So let's say you wanted to select columns 1, 3, and 5 from penguins. Well, you'd simply say penguins, and I'm going to pipe it into, I'm going to say penguins into select, and I'm just going to list the column numbers that I want. Right? So if I do penguin select 1, 3, 5, I'm going to get a data frame, a table. It's 344, which is the original number of rows, but it's only 3 columns wide, right? Because I've only selected columns 1, 3, and 5. Right? So let me stick that in. So I'll just one, 3, and 5. When I run this, what's going to happen, right? So you have a table 344 by 3, and you can scroll through. You can verify that this is, just a subset of the penguins data frame with only the columns that I wanted. Right. So the second way to select is to select by name, is to actually write by name. So here's a different one where I'm asking, how do I select species, island, and body mass G, right? Well, similar to before, I say penguins into select, and then I just list the columns that I want, right? I want species, island, and body mass, right? And again, I get 3 different columns because it wasn't the exact same columns that I chose before, but I'm going to get species, island, body mass. Right, so let me go back into my R markdown. What did I call that? Right. Right, again, just get those 3 columns. All right. So select by name is the one is the most common type of selection that I use personally. Maybe I should show another example, is that you can select using negative signs actually. So if I wanted all columns except island and species, I could do something. I could say penguins. So you can also use minus signs on the variables. And now I'll get all the columns in the data other than these 2, right? Now you can't mix the minus sign notation and the regular notation. So depending on, whether you want to keep most of the variables or you want to keep relatively few, you might want to use this minus sign notation. So I don't talk about that in the slides. I don't, but I think that's useful. All right. So to come back to, all right, so how to select by a function of column names. So there are a few functions that really useful to use in conjunction with select, which are starts with, ends with, contains, and matches. I'll just do some of these relatively simpler examples because I'm not trying to embarrass myself by getting some regular expressions wrong or something. So let's say that, so we notice in the data that multiple columns have measurements in millimeters, right? So let's just say we wanted to select all those variables, right? So let's go back to penguins, right? So in penguins, we see bill length, bill depth, and the flipper length are measured in millimeters, right? What if we wanted a data frame with those, with just those columns? We can use the contains function to match which is in the column names, right? So I'm going to do penguins into select and then call this function contains And when I run it, and when I output, so I save it to a data frame called penguins And when I output to the screen, I have 3 columns, which are just the bill length, bill depth, and the flipper length, right? All the column names that have millimeters in them. How do I get back? So I'll write this code here. Close this off. All right, so I'm going to save that. Right, so I'm going to use contains. Right, when you look at penguins you see just these 3 data frames. Right, so there's contains. Contains is one of the functions that's pretty useful. Another one is starts with, and then there's ends with, and then there's matches. That's a little bit more general, right? So a similar question is, how do you want to, what if you want to choose all the columns starting with bill, right? So we had a bill length and a bill depth, right? Sorry. We have a bill length in millimeters and a bill depth in millimeters, right? So I just want to keep these 2 columns in the data. What I can do is I can select, and I can select starts with bill, because I've looked at the data and I can see that these are the only 2 columns that start with bill. So I'm going to have bill's df, which is a name, and I do this, and I get a table, which is 344, but only 2 columns which meet the criterion that I selected. Right. So again, so let me see. Let's say choose. And right. I think Bill's DF is the name I used. So I'm gonna say penguins. Select. Starts with them. Right. See it over here. Just these 2. No, why did I do that? I don't want to do that. I don't want to do that. Sure. Okay, so I see a question here. So there's a question asking, do these functions only search the column names, or is it because the column names start with bill? No, so select is going to choose all of the functions that return that meet the criteria. whatever criteria you specify. I'm not sure if I understand the question. See, because I can't do starts with Bill. So this doesn't make sense, right? So that starts with Bill function only is a helper for select. It only works inside of select. Like you can't do it outside of select. So select is going to run, is going to do this check on the columns in the data frame passed to it. And anything that meets the criteria are going to be kept. Right? Okay. All right. All right. And okay. All right. And then another common thing you might want to do is you might want to select by type. And I'm bringing in something that I haven't talked about here, which is this where function. But I'll show it, which is the example. Is let's say I want to choose all the numeric columns, right? So the way to do it is to say penguin select. And what I'm passing into select now, what I'm using is I'm saying where is that numeric. And so where is a function that takes functions as its own input. So is that numeric is a function. Right? So what it's going to return is it's going to return a table, which is 344 by 5, right? And we see that all of the factor variables, the island, the species, the sex, is there anything else? No, so the island, species, the sex are gone. It's only the numeric variables, the flipper length, the build length, the build depth, the flipper length, the body mass, and the year are preserved, right? So let me go back here. All right, so in the slides, I don't give it a name, but I'm gonna say actually, yeah, let me not give it a name. Right, so I have 5 columns. Right, so you can do where, so numeric is a type. Okay. Here's another example. All right, so I'm gonna start. So the 5th way that I mentioned was to do a combination of any of the previous things. So here's an example of choosing all the factor variables or something that contains bill. So basically, I want the information about the penguins' bills, and I want the all the factor variables, the island, the species, and the sex, right? So I'm gonna say penguins into select. So I'm gonna use where is that factor because I want the factor variables. And then I'm gonna use or, this is the or operator, contains bill. So any column variable, any variable in the data frame that meets one of these 2 criteria is going to be preserved, right? So when I run this code here, I see 344 by 5. So what it does is it keeps the 3 factor variables, which is species, island, sex, and also the variables that contain the bill length, the variables that contain the name bill in them, right? So which is bill length in millimeters and bill depth in millimeters. So let me look at this code, right? So I'm going to say select or that contain, right? Yeah. So I'm going to use this as a factor for, yeah, let me, I get the same answer, right? So I get species, island, sex, build length, build depth. Now, if I had done that in the other order, what would have happened? Right, so if I do it in the reverse order, I get the ones that contain build first, followed by the factor variables, right? So as a kind of spoiler, well, so you can use select to reorder the columns of your data if you want. Right? All right. Next function we're going to talk about is mutate, right? Because sometimes you want to add more columns. And mutate is the function to do that. So what I'm going to do is I'm going to add a column that indicates whether a penguin has a mass greater than 4 kilograms. And in this example, I use strictly greater than as opposed to greater than or equal as I did before. So what I'm doing here, I'm going to say penguins. I'm going to send it into mutate. So mutate, just like filter and select, takes a data frame as its first argument, right? But I don't have to write it because I've sent it via the pipe, right? And I'm going to create a new column called above 4 kg. And I'm going to use if else. Now, if you're not familiar with Dplyr, this if underscore else is not the same as the if else in base R. It's a little bit stricter. But so it's a Dplyr. Let me see something in the chat here. Yeah. Okay. So I'm creating a new column called above 4 kg. I'm going to say if else. And the if else function, what it does is it tests a condition. And then if that condition is true, well, you specify what you set the value to if this condition is true. And then you specify what you set the value to if the condition is false. So what I'm going to do is, if the body mass is greater than 4,000, I'm going to make this above 4 kg variable true. And if not, I'm going to set this above 4 kg variable to be false. Right? Now, this doesn't show in the output here. So let me go back. Let me get as much space as possible. All right. All right, so what am I doing here? I am mutating, I'm adding a column. Right. So I'm gonna say penguins. Did I give it a name? Penguin extra. All right, so I'm gonna say penguins extra. So I'm gonna add an S here, right? So I'm gonna say penguins mutate above. All right, so wait, I did use the Dplyr if else. So my condition is, what's it, body mass. Let me break this. True. False. Should work. All right, so I have a data frame called penguins extra. Has 9 variables. So I created a new variable. When I scroll all the way to the end, I see my above 4 kg variable. And, you know, so this one is true. You see that this penguin is indeed greater than 4,000 grams. Right, so that's mutate. I think that's the only example I use of mutate. All right, next, we're going to talk about arrange, which is to sort. So example is how to sort all penguins by body mass. Just go say penguins and just say arrange body mass, right? Just go back. Right, so I'm taking penguins into arrange, and then I'm saying which columns I want to sort by, right? And this is the output here. You see that if I scroll all over to body mass, so all right, so by default it sorts in ascending order. So these, by default, you'll see the smallest, well, assuming that all penguins are equally dense, these would be the smallest, right? But these would have the lowest mass, right? Which is, 2,700 grams, 28. You see that these numbers are increasing. Hold on. Let me see. Sorry. Okay, so I'll go back into the code and do this. Okay. All right, so I'm gonna make, let's say penguins sorted. So there's two ways I can do this, right? So I can arrange penguins, and then I say what I want to sort by. So I want to sort by body mass, right? So right. So I'll go back to the traditional, the basic notation. I'm saying arrange. This is the data frame I want to arrange, and this is the variable that I want to sort on, right? Right, and by default, this is that this gets sorted by default in ascending order, or in ascending order by default, I think is a slightly better way to say that. All right. You can sort with multiple columns, right? So what if you wanted to sort by species and by body mass, right? So what I want is, let's say what I want is, I want each species, all the penguins to be together, but within the species, I want the largest body mass penguins first, right? So what I'm gonna do is I'm gonna say penguins, I'm gonna send it into arrange, and first level I'm sorting on the species, and then I wanna sort by body mass, but I'm gonna do it in descending order. So I'm gonna use this desc function, DESC, and pass body mass in it. So that will change the sorting order to us in descending order. So the largest penguins will come up first, right? So penguins 2, I'm gonna send it into arrange, and I'm sorting by 2 different levels now. So what that will show is, it will show all the adult penguins first, right? Then the chin strap, and then the gentoo, right? And within each species, the body mass is sorted, even though I didn't show you that column. Yeah. Okay, so I'm gonna do the same example of sorting on 2 levels, right? 2 sorting levels. Right. So let's say, I think penguin sorted 2 is the name that I use. I'm going to say arrange penguins species. All right, so penguin sorted 2. See all the species here. And if you look down the body mass column, the body masses are getting smaller. Right? And then I switch to the chin strap, and then you see among the chin strap penguins now, then they start to get smaller, right? So you see that the largest chin strap is larger than the smallest Adderley, but Adderley comes first. All right. Okay. All right. So now we're gonna move into summarize. So summarize. I'm gonna spell it with the S on the end and not a Z because that's how we spell things here in Trinidad. And yeah, but it is available in the Z spelling as well. So summarize. Well, when you're working with data, we often want summary statistics, right? We don't want 300 penguins. We want to find out, something that we could communicate on average or something like that, right? So here's a summarize command that's going to provide the number of penguins, the average mass, and the average flipper length, right? So I'm going to take penguins and I'm going to send it into summarize. Then I'm going to create new variables. I'm going to say num-penguins equal n. And so n is a Dplyr function that gives you the count of everything in our group. Now I haven't told you what our group is, but you will find out soon enough. But n will basically tell you how many things there are, right? So num-penguins, I'm going to say num-penguins equal n. I'm going to say average mass is mean of the body mass G column. I have to put in na.rm because I looked at the data and I saw that some of the penguins had missing data for some columns, right? So I'm going to take the mean of the body mass and then set this, basically saying ignore any NA values. And then similarly, I'm going to do an average flipper length. And I'm going to set it to be the mean of the flipper length and set na.rm equal true, again, just to ignore the few NA values. And when I run that, what I get is like a summary table. It says that there are 344 penguins. So this 344 came from this line here, right? You see the name num-penguins as the column name. Average mass. So you see it's exactly as I named it, right? And it's the mean. So that's where that calculation comes from. And then there's the average FL length. So it's exactly as I named it. So I didn't use the whole word flipper, and it came out here, and it took the mean, right? So I'm gonna go with R. Did I give it a name in the slides? No, so I don't give it a name. All right, so it's just a summary. Yeah, so okay, so I can do 2 ways, right? So I can summarize penguins, and I can say num. And so this is that. Is it average mass? I can't remember what variable. All right, so let me do it without the na.rm. So let me run it again. Right. So if I did that function as before, and I didn't have the na.rm, what would happen is the average mass and the average flipper length wouldn't be calculated because NAs are contagious in R. Right? So once you have one NA, everything goes NA. Right? So I'm going to stick in na.rm equal true, na.rm true. So I see a question in the chat here. So if you have a blank cell, if you have a truly blank cell, when you bring it into R, it's going to be NA. So this NA, so when we look at this data here, right, this NA is not the text string NA. This is a NA value. So this is saying it's a number that's missing. So that's different to, it's not the letters NA. It's a special value in R. All right, so that's me doing it that way. Now, I could have done it alternatively, just using the pipe, right? So right, so this is the code that I actually wrote in the slides, right? But just to show that, like, you know, the two different versions of like using the pipe first. Oops. This chat window. Right, and I get the same numbers, right? Sorry. Right. So that's what summarise does. That's the very first use of summarise. All right, so okay, we're about halfway. Yeah, I think we're on track for time. All right, but summarise gets really useful when you precede it by using group by. So what group by does is it creates a group data frame based on columns that you specify. So for example, I'm going to group the penguins by island and species by doing this, right? So I'm going to create a group data frame. I'm going to give it the name GR penguins. So everything that happens on this side here, I'm going to assign it to this name GR penguins, right? So I'm going to say penguins. I'm going to send it into group by, and I'm going to say I'm going to group by island and species, right? So, all right, so let's look at penguins in the console. Sorry, I'm seeing something in the chat here. All right, so let's look at penguins in the console. And I'm going to create a group version of penguins. I'm going to say group by. I'm grouping penguins. Was it species and island I want to group by? Island and species in that order. Yeah, let me do it the way that I do it in the slides. And because this is how I would do it in my own code, really. Right, so I'm going to run this. All right, so All right, so let's look at this. All right, so can we see both of them? I can't because this zoom bar is in my way, right? So if you look at penguins up here and the grouped version of penguins, they look pretty much the same, except for this line here. It says groups, island, comma, species, right? And that 5, and that 5 is telling us that there are 5 different groups in the data now. And those groups correspond to all the different combinations of island and species, right? So the grouping information is like some extra annotation added to your data, right? Right, so I'll just look at that. Right, so how is the group data frame different? Right, there was some extra information which we just saw there. Right, so rows that match on all the grouping variables will be in the same group. So in our case, if a penguin, 2 penguins that are on the same island and of the same species, they're in the same group right now. So that's why there are only 5 groups, right? There's only 5 combinations of island and species found in the data set, even though there's 344 penguins. Okay, so sorry, has a question. Somebody has a question. So, so the grouping information. So when I output it to the screen, all right. So let's look at when I output penguins to the screen, it just says a table 344 by 8, and it's just some data, right? When I output the group data frame to the screen, you have this extra line here, groups. And it tells you which variables were used to group by, and then it tells you a number, which is the number of groups. Right? So if I were to sneak in something here, count penguins, island, species, right? Right. So if I do a count penguins of island and species, I'll see that there are 5 different combinations, right? There's the island of Bisco, species Adelie, island of Bisco, species Gentoo, island Dream, species Adelie, island Dream, species Trinchap, island Torgerson, species Adelie, right? So these are the 4 combinations that exist in the data, and those correspond to these 5 groups. Right. Okay. Sorry. I don't even know how to get back. Right? Okay, so and rows that don't match on all the grouping variables will be in different groups, so different penguins, right? So now let's do a summary on data that has been grouped, right? So I'm going to take the group data and I'm going to send that into summarise. And I'm going to use the same functions the same variables that I calculated before, right? Num penguins equal n. Average mass is the mean of the body mass. And I have my na.rm equal true because I don't want the inconvenience of having NA values in my output. And I'm going to say average flipper length is the mean of the flipper length. Na.rm equal true, right? And so this is just as before, except that I have grouped this data before calling summarise. And when we see the answer here now, the table is a 5 by 5. So previously, the summarise function just gave me 3 numbers: the total number of penguins, the average mass, and the average flipper length. Now I'm going to get those summary statistics at the group level, not for the total population. So I have a group, let's say, so on the island Bisco, among the Adelie penguin species, there are on the island of Biscoe, the Adelie species, there are 44 penguins. The average mass is 3710, and the average flipper length is 189, right? Similarly, Biscoe Gen 2 is 124 penguins. The average mass is 5076, and the average flipper length is 217, right? And then you can see for every combination of island and species that's in the population, you get a count, an average mass, and an average flipper length, right? So I can do that. So I'm gonna call this, my penguins report. I'm gonna send that into summarize. Same code as from the slides. What I call it, average mass, mean of, see, true. Mean. Okay, all right. So, all right, now that's in red, which might bother you. It doesn't bother me, but I'll explain what that means later, right? So you get a little warning, but I'm not worried about it. I'm gonna ask you not to worry about a warning. How do I get, if I look at my penguins report, I see the same information that was on the slide. Right, so what grouping did was, so Summarise operates on all the groups in your data. And when we hadn't grouped, what it meant was that all of the data was in a single group, basically. So the default is to have all your data in a single group. But group by allows you to choose how to group your data. Right, so group by is what really makes Summarise more important, more powerful, I think. Okay, all right, so now we're going to talk about some, when I say new features to Summarise, is that they weren't in some of the older versions of Dplyr. So as of Dplyr 1.0, some of the things I want to talk about is that Summarise can give you summaries that return multiple values and summaries that return multiple columns. So here's an example of getting summaries with multiple values, right? So going with penguins, I'm grouping by as before. I'm just grouping on one level right now. I'm grouping by species. And in my summarize, I'm going to create a new column called RNG, which represents the range. And I want that to be the range of the bill lengths, right? So it's going to give me the range of the bill lengths in each group, right? The range being the minimum to the maximum. And again, I do NA.rm equal true because I don't want to deal with NAs. Well, I don't want NAs to affect my answer because that would just get NA, right? So, and let's see what his output turns out to be, right? So before, so we have 3 groups, but for each group now we have 2 numbers. And so this is an example of Summarise providing multiple values. So what you have is Adelie, you see 32.1. The column is named range, right? But it's 32.1, and then you see 46. So this is the minimum bill length of a penguin of the Adelie species. And this is the maximum bill length for that species, right? And this is for chinstrap, this is the minimum bill length, and this is the maximum bill length. And then for Gen 2 is 40.9 to 59.6, right? So this was something that wasn't always a feature of Summarise, where you could do So range is a function that returns two values, right? Not just a single entry, not just a vector of length 1. So summarize can now create something like this, where there's multiple values per group. So I'm gonna go back here. I'm gonna go penguins, right? What was it? Species? No, I want to group by. Right, so I want to group by, then send that into summarize. And I call it RNG, range. Actually, let's see. You see, so if I don't put the NA.rm, I get a lot of NA values. Because R literally says, I don't know what an NA is supposed to represent. Right? Okay. Then the other thing you can do is you can get summaries with multiple columns. Right, so this is, you could have created a new column before, right? So we could have done penguins, group by island, and then I want to say summarize. I'm going to create a table inside of the summarize function. And I'm going to say within that table, min mass is equal to min of the body mass G, and max mass is the max of the body mass G. And this is what I'll get, is I'll get this table with these two columns here. So summarize itself will have a table. So I want to group by island. So table. Is that correct? Let's grab that. Let's see, does that run? What's this? Okay, right. So I get min mass, max mass, right? So I could have created columns before as individual, but this is actually one object. And let me see what's on the next. Let me verify what's on the next slide. All right, so yeah, so I think if I give this a name, right, you really shouldn't copy paste, but just, you didn't see me doing this. Right. Let's say mass info. Right, so before I just stuff that table into summarize, if I give it a name, now this mass info column is a table itself, which I never used, but it is a feature of, so let me call it Penguins mass report. Right, so I'm going to do the summarize. So if I do penguins mass report, I use the $. If I use the $, I can base R. It has a data frame that's a column right? So there's a column of this object that's actually a data frame, right? If and so if you just view it by itself, it's going to tell you island and mass info is a table, right? But if you look at mass info, you see that right? So it is a table, right? So you can look at it, you can zoom in on it. I've never used that feature. But it's there. All right, so a couple other things I want to talk about groups, right? So when we did the grouping and we did the summarize, there was like a warning message. The grouping behavior in Dplyr is somewhat counterintuitive, I think. So what it does is, all right, so remember that it creates the groups. Hold on. Let me see. Where am I? Let's see. I didn't have it here. Okay. Okay, so I didn't actually have it. Okay, but when we created the group by, when we created the group by had tells you what the levels are. When you pass that into summarize, after the summarize does whatever it's doing, it removes a level of grouping. So this has two levels of grouping now, islands and species. After you summarize it, let me say, summarize penguins is, I'm gonna summarize GR penguins, num equal n. Right, so I get this here now. So let's look at summarize penguins. Right, so summarize penguins, by default, after summarize, it removes the last level of grouping. So this data now is not grouped on island and species. It's only grouped on island. So that's something that you have to be careful about. If you pass in data and you're assuming that it's keeping the same groups that you have, it's actually, every time you call summarize, it removes one level of grouping in the default behavior. You can alter that by using the dot groups function argument. I believe it's dot groups, but so you have to be careful about, yeah, so you have to be careful. So, and all functions will always be applied within groups. So you can use ungroup to go back to the original data, because sometimes if you don't ungroup, you get some funny stuff that's not really what you mean. All right. You can also use group by. So group by is most often used with summarize, but you can use it with mutate. So here's an example of using group by with mutate, where I want to give every penguin a number, or I want to give each penguin a number, but I want that number to be within its own species, right? So what I'm going to do, I'm going to penguins, I'm going to group by species, and then I'm going to say penguin num is 1 to n. So n would be the number in that species. And n would be the total count for that species, right? So let me type that out. Wait, let me see if I have it on the slides here, right? Okay, so it doesn't show the n. So going to say penguins numbered, say group by let's say mutate, what's the variable name? Penguin number. Right. So when I look at penguins numbered, all the way over to the end, I have a new column called penguin num that's going to increase by 1 for every penguin. I'm going to scroll through. And then I think, right, when I get to the end of the first species, I'm going to start over. Right? So every penguin has a number within its own species. Right? Sorry. Okay, time here. Okay, so that's an example of using group by with mutate. All right. Next function we're going to talk about is rename. Yeah, I think we're more or less on pace to like finish. Again, any complaints? All right, so rename works a lot like select, right? So we can rename by position. So here's an example of, so I've been typing these things and I'm getting kind of tired of typing the full length, right? So let's just say that I want to change the column name to bill length and not be bill length underscore mm, right? I can rename it by position. I can say I want new name. The way to use it is new name equal old name or old position. So I'm going to say bill length equal 3. So I want to change column 3 to bill length, and I want to change column 4 to bill depth, right? So I created a new data frame called penguins different, which is penguins with those 2 columns renamed, right? So you can select, this is a mess, right? You can select by position, or you can actually select the old name as well. So I'm going to rename by position. Okay, so I'm going to say penguins diff rename penguins, and I want to say that, yeah, that works. The length equal 3. All right, so I'm gonna give it a name, say it aloud. Right, so we see the name change to bill length or bill depth, right? You can also say, you can give new name equal old name. Right? So both of these work, either using the location or using the name. I think using the name is safer because, you know, if your data changes, you know, if your data source changes and the order that the column comes in is changed, then your code doesn't work, right? But both are available. So I don't know why I chose to use the number example, right? And then something else is you can use rename with, which to like specify like a specific transformation. So the example here is you can do penguins rename with, and I'm going to use just this one function here, toUpper. So toUpper is a function that takes a text string and makes it all capital letters uppercase, right? So so penguins, I'm going to pass it into rename with, And rename with takes a function, which could be two upper, two lowers, some other function that acts on a string. And here we see that in this new data frame now, the column names are all capital letters, right? And so it didn't have to be two upper. It could have been another function, or you could even write your own function. But I'm not going to do that today. That's a little bit too much, right? Oh, wait, hold on. Am I still sharing? I accidentally stopped my video for like a second there.
Yep, you're still sharing.
Okay, all right. All right. So,
You do have one more question.
Sure.
In the chat.
Yeah, again. Ooh. Oh man, Pavitra with a good question. I do not know. But let's see if mutate. It might be mutate. If so, what was the example with mutate? All right. All right. All right. All right. So I'm gonna do the same thing I did before, but I'm gonna have the groups on two different levels, right? All right. Right. So I've grouped by species and island. Let's see what that looks like. Right. So the groups turn over more quickly, right? So you have more groups. You have 5 groups. And let's see what that looks like. Oh, so mutate didn't remove the so mutate did not remove the grouping level. So the answer to that question is I don't know, but mutate would have been the one that I would have thought. So yeah, so I don't know. Mutate was the one that I thought might have been. Yeah. Is it recommended? Yes, I do think it's recommended to ungroup. That being said, I don't practice that personally unless it's, well, yeah, I'm not the best at ungrouping. But yeah, I think you should ungroup, pretty diligent, you should be pretty diligent about ungrouping, which is not my skill. But yeah, I usually have to have some like error. And hopefully I catch all my errors. All right, so, and then I have another example here with rename with, where, okay, so here's what I'm doing. Here, I'm renaming with 2 upper as before, but I'm also combining it with where is numeric, right? So it's only going to rename the columns that meet all of the, right? So that meet this where is numeric, right? So you see that in the output, the factor variables, the species and the island, remain in common letters, lowercase, and the numeric variables are changed to uppercase, right? So just to illustrate that rename with has a little bit of versatility, right? So let me install R. What am I doing here? Rename with So I'm renaming penguins. Right, so 2 upper, and then where is numeric? Was that error? That's what am I doing? What am I doing wrong? What am I doing wrong? So if I send this into, oh, no. Oh, yeah, so that is, right, sorry. So I was using both the pipe, yeah, I was using the pipe notation, right? So here we see species and island. Waiting for time. All right. All right, and then looking at another function, it's called relocate. It's a function which changes the order of your columns. So by default, there are 3 cases that it handles, right? One is that you give a list of names and it moves those columns to the front, which is the most common thing that you want to do, right? You want to bring something to the front. And then there are 2 columns where you say which columns you want to move, but then you specify that you want to move them before some other column. And then the other thing is to specify that you want to move them after the other column. I don't recall which examples I used, right? Now you could use select, but you use relocate in situations where like you want to keep all of your columns. You just want to change the order. So if you were to use select, you would end up doing more typing. You would have to type, and then it's not quite as flexible, right? So select, if you wanted to select and bring everything to the front, you would type the names of the columns that you want to bring to the front, and then you have to say, use the everything function to get everything else. Moving it, the other cases are a little bit even worse, right? You just have a lot more typing to do. So relocate is more like that, right? So here's an example. What if I wanted to bring all of the factor variables to the front? Because I think like sex is, where's penguins? Yeah. So like sex is a factor variable that's near to the end, right? So I want all my factor variables to be in front. Let's just say that's what I want, right? So I'm going to relocate, and I'm going to specify which columns I want to relocate, which is all that meet this criterion, where is factor, right? And I run that, and it relocates the, well, so species and island were always at the front, but it brings sex, which was down at the second to last column, into here, right? So, all right, piling up all this data. Let me close out all of these. Right, so that brings the 3 factor variables to the front. I don't do any examples. Okay, I actually do an example where, all right, so here's what I want to do is, I want to, right, so this statement here is wrong. So what's the probability that I make 87 slides with no errors? The probability is 0, right? So anyhow, so what I'm doing here is I am relocating, what the actual line of code is, I'm relocating the columns that contain the word bill after the body mass column. Now, I don't have a plausible explanation for why you'd want to do that. Um, somebody wants the presentation.
Oh, thank you. Since I could post it. Thank you.
Yeah. All right. So what this is doing is, I was just making up an example to demonstrate using the dot after or dot before, right? So I'm saying penguins, I want to relocate. And I want to say, I want to move the two columns. So let's say I'm interested in, build length and build depth being after body mass. I'm going to say relocate, right? Contains bill. And then I'm going to say, use the dot after argument to specify where I want it to be dot after, right? Um, is body mass. Right, so originally it wasn't in this order, right? So now I have body mass, and then the build length, then the build depth. All right. Okay, all right, so we get into, we have like 20 minutes left. So another function I want to talk about, well, which I'm trying to like start using is across, right? Which allows you to do like some column-wise stuff, right? So what if we wanted the average of every numeric column, right? The tedious way to do it is to group by. So let's just say we wanted this for species. I wanted the average build length, the average build depth, the average slipper length, and the average body mass, right? A tedious way to do it would have been to group by species, and then summarize. And then for each of these, I do a mean, build length, etc., etc. And that's a lot of typing, right? And I believe older versions of Dplyr had a function called summarise all, which kind of did something like this, but I never got it. So I found myself doing a lot of stuff, like, well, too much stuff like this. But now there's, right? So that's what that will give you, right? So for each species, it will give you the average build length, the average build depth, the average flipper length, the average body mass, right? All right, so here's a neater way to do it, right? Is to group by species, but within summarize, you can say across, and then you can specify across what, right? All right, so in my case here now, I'm gonna do where is numeric, and I have to add something extra here. So there is, the year is also a numeric variable here, right? But I don't want the average of the year. That's not particularly meaningful to me. So what I do is, and so I say where is numeric, and the column name doesn't contain year. So that's just my way of like hacking, getting away from finding the average year, right? So I'm saying across. So what the first thing you supply to across is like a specification of which columns. Then you give a function, or you can actually give a list of functions, I believe, right? But I'm just going to use mean, and then I pass any extra parameters here. I'm going to say na.rm is true, right? And this works here now. So instead of doing all that tedious typing now, for each species, I have the average build length, the average build depth, the average flipper length, and the average body mass. Yeah, I won't go back to typing that in because I think we're running kind of, make sure we get done in time. All right, so yeah, so just a little explanation. So that might have been a lot, right? So Let me just break down what across has. It has two primary arguments. The first one is the cols, which is the list of columns you want to operate on, right? And that's what this is returning, right? So that this expression here will give you the list of cols. And then the second argument is the function or a list of functions that you want to apply. And in this case, my function is mean, right? It can be a per style formula. I actually did do an example, I believe. Yeah, later on I do, but I'll skip that when that slide comes actually, right? But per is another thing, is another package that's kind of beyond scope, right? So, but that's what across takes, a list of, right? A selection of columns and a function or a list of functions. All right, you can do multiple summaries. So let's say that for each island, I want the average of all the numeric variables and the count of all the factor variables, right? So inside summarize now, I'm using across multiple times, right? So I'm doing across, where is numeric? I'm taking the average. So all the numeric variables, I'm gonna take the average. And then across all the factor variables, I'm gonna take the n distinct. N distinct is a function that tells you how many different values there are. So, and then I'll take n, which is the count, right? So let me bring this across here. All right, so what's happening here? So I do this in my summarize, I have two acrosses. So, all right, so we have the width here now, right? Everyone can see my screen, I'm hoping, right? So this is the output from this summarize. So first thing is for all the numeric columns, including the year, I didn't leave it out. For each island, I get the average, right? So this is the average bill length on this island, Bisco. This is the average bill depth on that island. This is the average flipper length on this island. This is the average body mass. This is the average year, right? So the years are 2007, 2008, 2009, right? So these columns here are from this first across. And then in the second across, I want a count of all distinct, meaning how many different values there are. So that will apply to the factor variables, which are species and sex, right? Because we have three factor variables. So we're grouping on island. So the other two are species and sex, right? So what this is telling me is that on Bisco Island, there are two species and there are three values of sex. And those will be male, female, and NA, right? Because remember, some of the penguins, there's no recording for whether they're male or female, right? So this is telling me on Bisco Island, there are two species. On Dream Island, there are two species. On Torgerson Island, there's only one species, however. And the N is this last function here, tells me how many penguins are on that island, right? So that's using summarize with multiple acrosses, I guess, is the plural of across, I don't know. All right, so, and here I use an example of across with filter. You don't have to use it with summarize, you can use it with other verbs as well. So for instance, how to get all rows without any missing values. So a lot of these things I just took from the Tidyverse blog where they use like other data sets, honestly. And, you know, but So here's an example where you want to filter, but you want to keep only rows that don't have any missing values. So I'm going to take penguins, I'm going to filter, and I'm going to use across everything. And I'm going to define my own function here, not is.any. So this is the function I'm going to apply using the across. So this is so remember I was saying you could supply like a per style formula. So this is an example of a function being defined by a per style formula. So it's a function that's going to check if there's an any in that column. So all of this is inside the across. All right. That might be kind of dense. Right, so this is the end of the filter. Right. So this is the column selection of across. This is the function and this is the end of across, right? So that's maybe kind of dense. We have a question in the chat here. Okay. Right. So across, just as when we were using across with summarize, you have to use a selection of columns and a function or a list of functions. So this is the selection of columns. This is the function. And instead of it being inside a summarize, it's inside a filter. Okay, so here's a question I asked. I'm not too sure what the answer is, to be honest. But so if I was to use the same thing, instead of using this per style function, I use the built-in complete.cases. And I'm not too sure, but so complete.cases is a base R function to find all the rows that have no missing values. So I think this is an equivalent piece of code. All right. What are we doing for time? All right, we're kind of running short on time. So I'm going to do penguins. Here's an example of penguins using distinct. So what am I doing here? Kind of lost track. Okay, so distinct finds all the distinct combinations of specified variables, right? So I'm going to pass penguins into distinct, and I'm going to say across, but I'm only going to do it across the factor variables. And I don't think that sort is, well, that sort is not very helpful. But what that does is it gives a distinct, it gives me all the distinct combinations of the factor variables. Right, but only the factor variables. So if I hadn't used the okay. Right, so yeah, so this is doing a distinct, but only across all the factor variables. And then here I have an example with count, where I'm doing a count across all the factor variables, and I'm sort equals true. So yeah, so this sort is actually not very helpful. So I should change the code. I'll modify this today, right? But what it's doing is that it's doing a count, and it's saying for all the factors now we get in a number, right? So it's telling you this combination occurs 22 times. this combination occurs 22 times. This other combination occurs 27 times, etc. Right, so all of which is to say, like, across can be used with any Dplyr verb. I think I'll skip this slide. Across will mutate. But what I will say is, this example I took from the Tidyverse blog where they use another data set, where like they create a rescale function to scale a variable from 0 to 1, right? So it scales a variable from 0 to 1, and then it creates a rescale column by rescaling across all the numeric variables. But yeah, I won't go into too much into that. But the code is there. And you can break it down. But you can see that all the values now in this data frame have been transformed to between 0 and 1. That's like because they've been rescaled, right? So the minimum value would be 0 and the maximum value would be 1. Yeah, so, and then another key thing is the row-wise operations. So sometimes you want to do like computations across the row, right? So I really couldn't come up with a good example for this penguins data frame. But so I came up with the example, like, let's just say we wanted a new variable that's the average of the bill length and the bill depth, right? If we were to, right? So you might think what you want to do is, so what I do here is I select the two columns that contain bill. So that will give me bill length and bill depth. And then let's just say I want to create a mutate where I want to average, and I want my average to be the mean of bill length millimeters and bill depth with my na.rm as always, right? This is what I'm going to get. And let me go back and write this code in. Sorry. Yeah. All right, yeah, so we're running short on time. So I think this is the last thing, or one of the last things. Right, so, all right, so if I run this select, it's just going to choose two columns, right? So now, I'm going to pass this into the mutate. When I run this, the problem is that all the average values turn out to be the same. Because this mean function, it takes the mean of the entire bill length. It takes the entire bill length vector and the entire bill depth vector and takes the mean of them. So what you get is, you get this average here, right? And the way to fix that is to send that into a function called rowwise. And what rowwise will do is it tells any downstream verb to like do a rowwise operation. So now you get the mean across the row, right? Right, so now we have a new column, which is the average. Now, I don't know if there's any, no, I'm not an ornithologist, but I just was trying to like find like a rowwise operation to illustrate. But so I don't know that it makes any sense to take the average of the bill length and the bill depth. Yeah. Right, so, and that's what I do right now, right? I take that output and I use the rowwise function prior to using the mutate, and I get averages that are different. Okay. Yeah, so we're running out of time. I think this is pretty much a good time to stop. In the slides, there's a couple of things where I go over like some other functions, which are joins, which is like joining, different data frames together, some binds, and then some other general, other useful Dplyr functions that I use in like exploratory data analysis. But I don't think we're going to get to be able to do that. But I think everything we've done so far is like, a pretty good coverage of like the data manipulation tasks. Well, I wouldn't say the data manipulation tasks, because I think the joins are also important functions. But I think that this is probably like a good place to stop.
Yeah, thank you so much, Daryn. I know all of us definitely, wanted to see the rest of the presentation too. It was so great. I mean, I learned a ton. I haven't been using Select to its fullest extent. Wasn't aware of across. So I mean, just anyway, I was taking notes as you were talking and going through the slides with you. We really appreciate, you giving us a presentation. For everyone on the call, we are going to upload the video or the recording of the talk to our YouTube channel. I'm going to post that channel in the chat right now, so you can subscribe. So when we upload it, you'll be notified. Is there any, I guess, like last notes you want to mention, Daryn?
No, I was also like, I just skipped to my last slide, just showing like,
Okay.
Just pretend I didn't. That was actually. But yeah, so I just say, Dplyr has a lot of good resources. The package vignettes, the Tidyverse blog, in particular, there's a RStudio community posts that I found a lot of the Tidyverse blog entries specific to the Dplyr. So I linked to that in the slides.
Awesome.
Right. And there's lots of resources, and thanks to everyone. Thanks to everyone for sticking around for 2 hours, and my employer for allowing me to use the office and the time to do this.
Yes, thank you, Daryn's employer, and thank you, Daryn, and thank you all for joining. I really appreciate it. All right, well, with that, I will wrap this up. Have a good day, everyone.
All right.
And night.
All right, I'm going to stop sharing. Yeah.
Okay.